Good afternoon, everyone. My name is Roberto Santos, and today we are talking about HydroML, a system developed for improving the quality control subsystems at the Belize Climate Data Management System. We focus on rainfall and river level data. HydroML was sponsored by the World Meteorological Organization and in particular for the Hydro Hub initiative. And it's developed by the company Eligence in partnership with the National Meteorological Service of Belize. The project goes for the HydroML were the development of framework for the automatic training and execution of machine learning models to classify hydrological measurements, and the development of a web-based system released under an open source license to enable the adoption by other national meteorological or hydrological services. And finally, the integration of this tool, HydroML, with Surface, Belize's climate data management system, for improved the reliability of hydrological information. In order to test the system, we chose a specific area of Belize, as you can see in the top left uh, red square. That's quite important because it converts a number of different weather stations and hydrological stations, and we have a point that's very prone to flooding. So having good quality information, environmental hydrological information in this area is fundamental for planning, interventions, and also for the protection of the population. So this area contains 4 stations. The one that we are implementing the quality control, that's called Hawksworth Bridge, and is a hydrologic station that is surrounded for other 3 stations: Santa Elena, another hydro, and 2 weather stations, Central Farm and Chalk Creek. The end goal of the project is to generate a screen like this one. That's a number of models based on training data provided by the user. And these models, they have been trained with different parameters so that the user can play and test which models are best fit for his or for her scenario. And these models now can, given input data, can predict what is the quality of that data. All these models for rainfall, that's what we're showing this screen, they are binary classification. That means 0, 1, bad or good data. That's what the model returns to the user. The integration with Belize involved 5 steps. One was the development of a web a REST API that would expose those trained models for inference or prediction. So external systems like Surface now can make calls to the REST API to get sending a payload with new data, and this can go through the models that will run a prediction and return what is the result for each measurement that was sent in this call. We also extend the surface data model so that we could ingest this result back into the surface. So at the moment, Surface has 3 traditional quality control techniques, and we had to extend the data model in order to support a 4th type of testing. That's the one coming from HydroML. Once we have the REST API and extended model to ingest the data back into Surface, we had to develop an asynchronous task so that on the Surface side, so that from time to time it would grab all the recent measurements that uh, haven't been through the quality control process, sent to HydroML, for prediction. And this is done via an asynchronous task implemented using celery package from Python. Finally, we have the last two steps: the conversion of the HydroML labels into the surface quality control flags. As I said, on the surface we can have multiple flag systems for the quality control, whereas for the HydroML is a binary classification. So we only have zeros and ones, good or bad data. And we need a place where we can make the lookup table between those two systems. And finally, update of the surface so that users could visualize the results of the ML classification.